So today we are going to start a new topic on mathematics, Determinants, chapter 4 in Ncert. Okay, mathematics, Ncert math, chapter 4, no? Determinants. We need to have a small introduction on what is determinant. Since your concept about the matrices is very clear, understanding the determinants would be very easy. The one who started this matrices, the one who developed these matrices, gave all its properties to determinants. Is it okay? There must be a particular person or a group who has developed these matrices, right? Okay. So the properties of all that matrices has been given to these determinants. Now, first case is representation. In matrix we have learned that it's a rectangular arrangement of numbers. Okay, it can be of any order. Matrix can be just one row and one column. Matrix can be it can be 1 cross 3 matrix, it can be 1 cross 2 matrix, it can be 2 cross 1 matrix, it can be 2 cross 3 matrix, it can be 3 cross 2 matrix. Matrix could have been any order. Matrix can take any order. Alright, it can be square or it can be rectangular. But determinants is always rectangular. Is it okay? In matrix, the order is not necessary that the number of rows and columns are equal. I don't know. It can be. If the number of rows and columns are equal, then we call it as a square matrix. But it's not necessary that the number of rows and columns are always equal. It's not necessary that it's always square. Okay? But in determinants, the number of rows should always be equal to the number of columns. That's the most important part. Okay. Now, so a determinant is always in square form. Okay. 어떤 square form을 타기보다게 where the number of rows is equal to the number of columns. Okay. Physics the column So in determinants, the number of rows is always equal to the number of columns. Here in this case, number of rows may or may not be equal to the number of columns. But it is always defined for matrices. For determinants, it is not so. Now, we use determinants to find the numerical value of a given matrix. Are you clear about that? We use determinant to find out the numerical value of a given matrix. In matrix, suppose if A is any given matrix, 1, 2, 3, 1. If A is any matrix, then in order to find out the numerical value of this matrix, see, A is just an arrangement, some arrangement. In order to find out the numerical value of this matrix A, this is where determinant comes into play. Using determinant, we find the numerical value of a matrix. Is it okay? Yes. Now, matrix had only limited properties. We can add 2 matrices. We can subtract 2 matrices. We can multiply 2 matrices. We can multiply a matrix by a scalar, right? But we cannot expand a matrix. Is it okay? So in order to expand a matrix, we need a certain quantity. We need something known as determinants. Alright? Now in matrices, all the numbers or all the terms are arranged inside these square brackets, right? Inside this square bracket. We call this a square bracket, no? But how do we represent a determinant? If this is your matrix A, then if I write it in determinant form, then I have to write determinant of A. this A should be enclosed within 2 bars, 2 vertical bars. It's not a modulus, okay? Modulus is also represented by 2 vertical lines, right? But this doesn't mean that it's a modulus, okay? Modulus function is different. So, okay, a determinant, in order to represent a determinant, then we always need 2 vertical lines. Determinant of A, suppose A is your given matrix. Determinant of A means I have to write A within 2 bars. And this matrix 1, 2, 3, and 1, okay, here it is written in squared bracket, but we need to write all the entries of the given matrix within 2 vertical lines. This is how we represent a determinant. That's a small introduction on what is known as determinant. Are you following that? Is it clear to you? Okay. So basically, we need determinant, okay, to find the numerical value of a given matrix, but only square matrix, because determinant should always be in square form. Means the number of rows should always be equal to the number of columns. Okay. Suppose if a given matrix is in a given matrix, if the number of rows and number of columns are not equal, if it is not a square matrix, then we cannot find its numerical value, because we cannot use the determinant over there. Is it okay? Yes. Now let's see, how do we expand this determinant? How do we expand this determinant? That is what we are going to see. It's very simple. We always start with 2 cross 2 matrix or 2 cross 2 determinant, okay? We will first start with of order 2. Suppose A is a given matrix 1, 2, 3, 4. I want to find determinant of A. It will be represented like this. They may say, a question can be asked in this way: find determinant of A. Okay? Or they can give in this form: find determinant of A. Is it okay? Find determinant of A. Alright? It can be given in any form. There should be no confusion. Okay? Only 2 forms. Now, in order to find the determinant of a 2 cross 2 matrix, so A is a given matrix, so determinant of A is equal to determinant of 1, 2, 3, and 4. Okay, for order 2, finding the determinant is very simple. Just you need to cross multiply the given entries. Okay, these are the entries, right? So you need to cross multiply the given entries diagonally. What are the diagonal elements here? Or if we go along the diagonal, then 1 times 4, 1 times 4, we write minus, and we multiply the anti-diagonal elements. We first multiply the diagonal elements, and then we subtract the anti-diagonal elements. Is it clear? So let me represent the anti-diagonal elements by dotted lines. Right? 3 times 2. So 1 times 4 is 4, 3 times 2 is 6, 4 minus 6, minus 2. So the numerical value of this matrix is minus 2. Ensure that determinant is minus 2. Are you getting that? So finding the determinant of order 2 is very, very simple. Okay? We first multiply the diagonal elements, and then we subtract with the anti-diagonal elements. Okay? Now, what happens if you are given a 3 cross 3 matrix? How do we find its determinant? Let B be any matrix. Let B be any matrix 1, 2, 3, 0, 1, minus 1, and 2, 4. Let's say 3 over here. Okay, I'm taking the smaller values only. Okay, so that our multiplication is easy. Now, question is: find determinant of B. Now, determinant of B is determinant of 1, 2, 3, 0, 1, minus 1, 2, 4, 3. Okay? Now, you see, this one, there are, in this determinant, there are 3 rows and 3 columns. Na? Yeti 3 row ase, aru 3 column ase, 3 rows and 3 columns. You can expand along the first row, the second row, the third row. Or you can expand along the first column, the second column, and third column. You can expand it in any way. Is it okay? I will teach you some of the ways. Like, suppose I want to expand this determinant along R1, along the first row. So expanding along R1. Let us expand this determinant along R1. Now, the first element of your row 1 is, what is the first element of R1? 1, right? So your determinant of B will be equal to, the first element of R1 is 1. When you consider this element, okay, when you consider this element, what you do is, this element belongs to this row, this element belongs to this column. This element 1, this entry 1, it belongs to the first row and first column. You will neglect those row and column. And you will cross multiply. You will cross multiply the remaining elements as you did in 2 cross 2 determinant. Is it okay? That means I'm going to multiply the remaining elements diagonally. 1 times 3 is 3. Minus multiply the anti-diagonal elements. Is it okay? 3 times minus 1 is minus 3 again.
4.
Oh, I'm sorry. 4 times minus 1 is minus 4 again. Is it clear to you? No? Or there is one more way. Suppose I'm expanding along R1, so the first element, the first entry is 1. This element belongs to first row, first column, so we will neglect that particular row and column. And then we write the determinant of the remaining elements. Okay? We write the determinant of the remaining elements. 1, minus 1, 4 and 3. Okay? Is it clear to you? Okay. So, this 1, 2, 3. This is 0. Now we consider the second element. Okay? What is the position? What is the position of this element? Yeah. A, 1, 2. This element was in first row and first column. Let us represent all the elements by A. But this element is present in first row and first column. 1 plus 1, 2, even. So we take positive sign. Now, the next element of your first row is 2. Okay. So this element, all the elements we represent by A, right? This element is in first row and second column. First row and second column. 1 plus 2, 3. Odd, right? If it is odd, then I will write minus there. Are you getting me? And this is 2, right? When we consider this element belongs to first row and second column. So we will neglect this row and column, and we write the determinant of the remaining elements in the same order. 0, minus 1, 2, 3. Next we will have, now the next element will be a 1, 3. 1 plus 3, 4, even, plus. Alright? Now when we consider this element, what we do is, this element belongs to the first row and the third column. So we'll neglect this particular row and column. Okay, the next element is 3, right? And we write the determinant of the know how to find out the determinant of a 2 cross 2, okay, of order 2. So 1 as it is, we first multiply the diagonal elements, multiply diagonally, 3 into 1, 3, minus, and we will multiply the anti-diagonal elements. 4 times minus 1 is minus 4. Is it alright? Now we have minus 2 here. Again, 0 times 3 is 0, minus 2 times minus 1 is minus 2, plus 3. 0 times 4 is 0, minus 2 times 1 is 2. Is it okay? Is it clear? So 1, 3 minus minus plus 4, minus 2 into 0 minus minus plus 2. Is it correct? Plus 3 times minus 2. So that's 1 times 7, minus 2 times 2. 3 times minus 2 is minus 6. So that's 7 minus 4 minus 6. 7 minus 4 minus 6. 7 minus 10. That is equal to minus 3. So that is how we find out the determinant of order 3. Or we find out the numerical value using determinant of a given 3 cross 3 matrix. Is it okay? Using determinant, okay. So the first exercise of chapter 4, that is exercise 4.1, is only about expanding the determinants, or expanding, okay, a determinant, okay. So let me see the first question. Evaluate the determinant. So there is a given determinant and we need to evaluate it. We need to find its value. Exercise 4.1, question number 1. Okay, the question is evaluate the determinants. The first question is your given determinant is 2, 4, minus 5, minus 1. Okay. Determinant we usually denote by capital letter delta. This is your capital letter delta. This is your small letter delta. Okay. Small letter delta we usually denote using differentiation, but capital letter delta we use it for denoting a determinant. Okay. So this is your given determinant. So let delta be your given determinant. Okay. 2, 4, minus 5, minus 1. So this is a determinant of order 2. So expansion will be very easy. We first multiply the diagonal elements. 2 times minus 1, minus 2. Minus, and we multiply the anti-diagonal elements. Minus 5 times 4, minus 20, right? So that is minus 2, minus minus plus 20. 20 minus 2, 18. So the value of the given determinant is 18. Is it clear? Okay. We can try some more questions. Suppose question number 2, Roman 2. The given determinant is x square minus x plus 1, x minus 1. Here x plus 1, here also x plus 1. Okay. Now, let delta be your given determinant. X square minus x plus 1, x minus 1, x plus 1, and then x plus 1. So we need to find its value. So what we do is we simply multiply the diagonal elements first. So x square minus x plus 1 to be multiplied with x plus 1. minus, and then we multiply the anti-diagonal elements. X plus 1 times x minus 1. Is it alright? This is following some pattern. This is following some identity. A cube minus b cube, or a cube plus b cube. A plus b. A square minus ab plus b square. I think this particular product follows this pattern here. Now satisfies this formula, because this one, this is of the form a plus b. This is your a plus b, and this is your a square minus ab. X into 1 is x, plus b square, 1 square is 1, right? So this is following a plus b, and this is your a square minus ab plus b square. So a plus b times a square minus ab plus b square is a cube plus b cube. 1 cube is 1. Minus. This is following the pattern a plus b times a minus b. That's a square minus b square. We have a negative here, so we have used parentheses. So x cube plus 1 minus x square plus 1. So that is x cube minus x square plus 2. So this is your required value. Is it alright? Like that, the same way you can try the rest of the things for 2 cross 2 determinant. Now let's see question number 4, which is your, let's see question number 4. It's the order is 3, and we have already seen how to find out the determinant of order 3. So with that concept, we will work on with question number 4. Question number 4, it's given that if your A, or A is a matrix, okay, given is A is a matrix. Given is a matrix, say 0, 1, 0, 1, 0, 1, 2, and 0, 0. So this is your matrix A. Now you want to show that. Determinant of 3A. If A is a matrix, 3A also will be a matrix, right? If A is a matrix, then 3 times A will give you another matrix. So you need to find out the determinant of that matrix. Is it okay? Do not get confused yourself that determinant of 3A is never 3 times determinant of A. No. It is not equal. Okay, these are 2 different things. Alright? Okay. When you are talking about 3 times determinant of A, then first you need to find out the determinant of this matrix, and with the result you multiply by 3. Okay? But here you are asked, okay, to prove that determinant of 3A is equal to 27 times determinant of A. Determinant of 3A means if A is a matrix, then 3A will give rise to another matrix. So you have to find out the determinant of this particular matrix 3. Are you getting that? Yes. And on the other side we have 27 determinant of A. That means first we need to find out, since we know the matrix A, so we find determinant of A first. And with the result you multiply by this scalar 27. Are you getting that? Yes. Okay. So I'm going to start with the left hand side. In order to find out the determinant of 3A, I need to find out the matrix 3, right? So 3A means 3 times your matrix A, 1 0 1 0 1 2 0 0 4 4. If you are multiplying a matrix by any scalar, then all the elements, okay, should be multiplied by the scalar 3. So 3 0 3 0 3 6, is it correct? 0 0 and 12. Is it alright? Now we find out determinant of 3a. Determinant of 3a means determinant of 3 0 3 0 3 6 0 0 12. Alright? We can expand along. Which column or which row has more zeros? We expand along that. So which column or row has more zeros? The row 1. No, row 1 has only 1 0. Yeah, column 1 has 2 zeros. Column 2 also has 2 zeros. So it will be easier for you if you expand along column 1 or column 2. Alright? For me, I want to expand along column 1. So expanding along C1, then your determinant now will be equal to C1. The first entry of C1 is 3. It's 3. Yeah? Now 3 belongs to the first row and first column. So you will neglect this row and this column. And you will write the determinant of the remaining values. Okay? 3, 6, 0, 12. 3, 6, 0 and 12. You can just multiply directly. So okay, I'm just writing the extra. Okay. Next, minus of the next entry of C1 is 0, 0. Now this entry belongs to the second row, right? Second row and first column. So leaving out second row and first column, you will write the remaining entries. 0, 3, 0, 12. 0, 3, 0, 12. And we write plus. Now the last entry of C1 is also 0. So this 0 belongs to the first column and the third row. So leaving out the first column and the third row, we will write the determinant of the remaining values. 0, 3, 3, 6. 0, 3, 3, 6, right? So this is equal to 3. 3, 12 times is 36 minus 0. Minus 0. 0 multiplied with any determinant will be 0. 0 multiplied with any determinant will also be 0. Okay. So this is 3 times 36 is equal to 3 6 times is 18, 3 3s are 9, 108. It's 108. It's correct. 303 036 0012. Okay. Maybe it's correct. Okay. Let's make sure that it's correct. Okay. Now your right hand side. Your right hand side we have 27 times determinant of A. So 27 times your determinant of A. What is your determinant of A? Your determinant of A will be 1 0 1 0 1 2 0 0 4. The column 1 and column 2 has more zeros, so expand along either column 1 or column 2. So expanding along C1 shall we? So 27 and times the first entry of column 1 is 1. We neglect this row and this column. So we write the metric, or we write the determinant of the remaining entries 1, 2, 0. The next element is 0. So we have to write minus, and the next entry is 0. Alright? So if you consider, if you are taking this entry belongs to the first column and second row. So we neglect that row and column and we write the determinant of the remaining values. 0, 1, 0, 4. Plus the next entry is 0, right? So we neglect the first column and third row. And the remaining entries are 0, 1, 1 and 2. And then the expansion is done. Alright? I'm going to write here. So this is equal to 27 times 1 into what we multiply the diagonal elements. 1 times 4 is 4 minus 0 times 2 is 0. And then we have minus 0 plus 0. Alright? So this is 27 times 4. Okay? So 4 7 times is 28 to carry 4 to the 8. 90. So your result on the right hand side is 108. The result on the left hand side is also 108. Therefore, left hand side is equal to your right hand side. Hence, the given condition has been verified. Alright? Okay. So you can start solving out the entire questions of this exercise. Okay? It's better if you don't miss a single one.
Did you draw this one on purpose or does it mean something?
No, this one I was just making a spectacle out of it. Okay.
We never know what symbol.
Yeah.
You will see.